Hey there, hope you're doing well. We are going to be graphing the cosine function. Now, we're going to graph a variation, so to speak. It's not the parent graph. I'm assuming you already know how to graph the parent graph of cosine, and if you're uncertain, let's quickly walk through it so you can see some of the attributes of this cosine graph. So remember, you split the graph into 4 intervals because it represents each quadrant. So we've got what? Pi over 2, pi, 3 pi over 2, and then 2 pi. And so cosine, remember, when you're dealing with the grid system, cosine deals with the x value. And at each of these 4 angles, you have got a point. And so since cosine deals with x's, that means you need to know what the x value is at each of these particular angles, which represent each of the axes. So when you're looking at the cosine of 0 radians, the answer is 1, because that's the x value. When you're looking at the cosine of pi over 2, the x value is 0. At pi, it's -1. At 3 pi over 2, it's 0. And then back to 2 pi, it's 1. So the parent graph of cosine looks like this. Now, that could keep going. It's a stamp, right? And so the domain is -infinity to +infinity, and the range goes from -1 to +1. Now, something I'd like you to notice, let me write down what we just graphed so everybody's on the same page. Something I'd like you to notice, and I'm going to compare it to what we really want to graph, is the range is from -1 to +1. If you remember, there's this thing called amplitude, and amplitude dictates the range and is actually found multiplied next to the cosine function, and the sine function for that matter, but we're dealing with cosine. So in front of this cosine function is the number 1, and that tells you the range is from -1 to +1. So now that we've refreshed our brains on this, let's go over here to this particular function that we want to graph. And the first thing we always identify is the amplitude. And the amplitude is always the number multiplied to the cosine. And in this case, your amplitude is 3. And the amplitude dictates the range. And the range will be then from -3 to +3. So basically, that 3 stretches the graph in the vertical direction. Cool? Okay. So now, if we want to graph this cosine function, it's supposed to go from -3 to +3 on the range. Nothing was shifting my angle measurements, so I still have our typical angles at the 4 axes on this grid system. Good? Okay. So, on the parent graph, 0 radians, take the cosine of 0 radians, you get 1. But according to this, after you get 1, you're supposed to multiply by 3, which gives you 3. On the parent graph, when you took the cosine of pi over 2, you got 0. Well, over here, you also get 0. And forgive me, this graph didn't quite hit all the dots like it was supposed to. There, better? Thanks. On the parent graph, the cosine of pi was -1. Well, over here, after you get that -1, you multiply by 3, you get -3. See the pattern? See what's happening? It's still the same graph, but every y value is getting multiplied by 3. So still going to get 0, and instead of getting a +1, you'll get a +3. So I still get the graph of cosine, but it's been stretched vertically. Are y'all with me? So in this case, remember, this is a stamp. The domain is still going to be -infinity to +infinity. I'm just going to keep going around the circle, and this same thing is going to happen. But now the range, as dictated by the amplitude, is going to be from -3 to +3. Are you with me? Okay. So I have some examples coming your way. They're going to deal with some other attributes, shall I say, characteristics of graphing the cosine function. So this is going to be good for you to remember is the parent graph of cosine and how we get the 1, the 0, the -1, the 0, the 1 again, and what the domain and range is of the parent graph, okay? Because that's going to help us when we graph some of these other cosine functions. Work on them first, go find my answer key video, and I'll catch you on the flip side.